All right, this is the video for the sample test on Unit 8 for Algebra 2, Sequences and Series. On this test, we're going to use our graphing calculator and we're going to use the formula sheet for Algebra 2. So let's start with number 1. It says write the first 4 terms of the sequence defined by, and then we start out and I tell you t sub 1 is 3. So we know right away that's the first term. The second part of this formula says t sub n. So to get the next term, you're going to do negative 2 times t sub n minus 1, which is the term before that. And then at the end here, we tell you n is greater than or equal to 2. That just means that we want future terms, not going backwards, and we can pretty much ignore it. All right, so let's find the next term. To find the second term, we're going to do negative 2 times the term before it. Well, the term before it was a 3. So negative 2 times 3 is negative 6, and that's the second term. To get the next term, again, I'm going to do negative 2 times the term before it. Well, the term before it was a negative 6. So negative 2 times negative 6 is positive 12. We want one more term here. To get the next term, again, I'm going to do negative 2 times the term before it. The term before it was a 12. So negative 2 times 12 is negative 24, which is the fourth term of the sequence, and those are the first 4 terms of our sequence. Number 2 says show the expanded series and evaluate. The expanded series just means write out all the terms. Well, this has to be an explicit formula, which it is, and I'm going to start out by plugging in the number on the bottom. So I'm going to plug in a 3. So I'll have 3 squared minus 2 times 3. So if I do that, that's 9 minus 6, which is 3. So that's the first term in my series. For the second term, I'm going to do the same thing, except for now I'm going to plug in a 4. So I'll have 4 squared minus 2 times 4. So that's 16 minus 8, which is 8, and 8 is the second term in our series. Then I'm going to plug in a 5. So I'll have 5 squared minus 2 times 5. So that's 25 minus 10, which is 15. 15 is the third term in our series. I just plugged in a 5, which is the number on the top of my sigma, so I know I'm done. This is the expanded series, 3 plus 8 plus 15, and then the sum of the series would be 26. That's what it means when it says to evaluate. It means find the answer if you added all of the terms together. Number 3 says to evaluate the following expression. I can tell when I look at this that it's geometric. Sometimes you guys can't notice that, and it's helpful to start out and write out a little bit of our pattern. So I can tell the first number I would plug in is a 1. So I'll start out and I'll write out 1/3 times 1.1 to the first power. The second thing I would plug in is a 2. So I'd have 1/3 times 1.1 to the second power. Then I'd plug in a 3. And I'd now be to the third power. And I'm going to keep going until I plug in the last number on the top. So I'd be plugging in a 25, and I'd have 1/3 times 1.1 to the 25th power. Now I want to type this into my calculator to see what I get, and it will give me a decimal. I can hit my FD button right there if I want to turn it into a fraction, and I can tell my first term is 11/30ths. So I'm going to write that down, 11/30ths. Then I want to find my second term. So I type that into my calculator, and again I can hit the FD button and turn it into a fraction, and I see my second term is 121/300. I could keep going with this pattern, but already it looks to me like it's geometric. It looks like I'm multiplying the top of my fraction by 11 and the bottom of my fraction by 10, which is 11/10ths, or 1.1 from the formula. So I feel confident now that I'm geometric formula with a common ratio of 1.1. I'm looking for a sum, so I need to know how many terms I'm going to have in my sum. My formula for a geometric sum is S sub n is a sub 1 times 1 minus r to the n all over 1 minus r. So let's see, I'm trying to find the sum of the first 25 terms because up here on the top of my sigma, I can tell I have 25. So the sum of 25 terms. Next, I need the first term. I found the first term over here all the way on the left was 11/30ths. So I'm going to put that in. And then I have 1 minus my common ratio. My common ratio, I knew from the formula, was 1.1. and that again is going to be raised to the n power, which was 25, and all of that was over 1 minus the common ratio. So I typed this into my calculator using parentheses, the same places I had them in my original formula, hit enter, and I get this decimal. If I hit the FD button on this one, nothing happens. That's because it's too complicated for our calculator to figure out, but that's no problem. Our answer is 36.0605. I'll give 4 places to the decimal, and then I'll just chop it off. If the answers were multiple choice and they were fractional answers, you could just convert the answers into decimals and see what matches up. All right, number 4, find 2 arithmetic means of 20 and 37. This means if I have 20, I'm going to have 2 terms in between until I get to 37. The fact that they're arithmetic means is what tells me that every time I'm going to add the same common difference to get to the next term. So what I have is 20 plus 3 of my d's have to make me get up to 37. I can then solve this equation by just using plain old algebra. I'll subtract 20 from both sides, and then I'll divide both sides by 3, and I get my d is 17/3. So now I'll come back to my pattern, and I'll add 17/3. You can use your calculator to do that if you want to. 20 plus 17/3 is 77/3. So there's my first arithmetic mean, 77/3. And then I'm going to add again 17/3. Which gives me 94/3 as my second arithmetic mean. So those are my 2 answers. Whenever I'm doing means, I always think it's a good idea to just double check. If I add another 17/3, does that get me to 37? And you can see on my calculator, I added again and I got 37. So I know my means worked out. All right, let's scroll down here to number 5 and 6. So on number 5, it says, given this pattern, I need to find S sub 20. I should know that S sub 20 is the sum of the first 20 terms. So I need to figure out, is this an arithmetic or a geometric pattern? Well, every time I'm adding 3 to get to the next term, so I can tell that this is arithmetic with a common difference equal to 3. I can use either of my 2 sum formulas. Since I don't know the last term, I'm going to go with the second of those 2 formulas. S sub n is n over 2, 2 times a sub 1 plus n minus 1 times d. You could also use the first formula, but then you'd have to plug in and figure out what the 20th term is. So I'm finding the sum of the first 20 terms. So that means n is 20. So I'm going to plug in 20 on the top of my fraction. Then I have 2 times a sub 1. A sub 1 from my list is 4, so I can plug that in. Then I have n minus 1, so that's 20 minus 1. And then I'm going to multiply that by the common difference. The common difference when I found my pattern was 3, so I'll plug in a 3. Now I just need to evaluate this on my calculator. I have 20 divided by 2. I'm going to put that in parentheses because it's a fraction. And then I have 2 times 4 plus, I'm doing 20 minus 1 times 3. I think it's easier to just do 19 times 3 rather than worry about another set of parentheses. And that gives me my sum of 650. So that's the answer, 650. Number 6, find 3 geometric means of 20 and 5,120. So this means I'm going to have 3 terms in between 20 and 5,120. And also because they're geometric means, that tells me that every time I'm going to multiply by my common ratio to get the next term. So I like to lay it out so I can see it. And I can see that what I'm starting with here is 20. I'm going to take 20 and I'm going to multiply by 4 r's, so that's r cubed, and my answer has to be 5,120. So now I just need to solve this equation to figure out what r cubed is, so I'll divide both sides by 20, and 5,120 divided by 20 is 256. To get rid of the fourth, I'm going to take the 4th root, I know that that's 4. Technically, it could be plus or minus, but it is 4, and you could do that on your calculator by typing 4 and then shift and the exponent button, 256. If you have your TI, to get that little xth root, you go into math and you scroll down and it's right there. So we can tell our common ratio is 4, so now I just need to fill in the missing parts. If I had multiplied by 4 each time, 20 times 4 is 80. 80 times 4 is 320. 320 times 4 is 1,280. And then just to double check, does that times 4 equal 5,120? Yes, it does. So you know that those are my 3 geometric means. Number 7 asks us to write the explicit formula and also the recursive formula for the nth term of the sequence that begins as follows. So I got to look at my sequence and figure out what is my pattern here. What do I do each time to get to the next term? Well, I'm subtracting 5 each time, which means that this is arithmetic, and our common difference is -5. So if I'm going to start out with an explicit formula over here, in general, the explicit formula for arithmetic is a sub n is a sub 1 plus n minus 1 times d. So in my explicit formula, I'm going to leave in the n minus 1. I need to plug in my numbers for the first term and for d. So my first term in this sequence was a 7, so I'm going to fill that in. And then I also figured out my common difference from my pattern was -5. Be sure when you write that you put the -5 in parentheses or it looks like you're subtracting 5. So this is a fine answer. The other thing that you could have done with that is you could have simplified by distributing the -5, and then we'd have 7 plus -5n plus 5, which we could then rearrange and call it -5n plus 12. Again, I don't care which version you write, but if it were a multiple choice and the option was -5n plus 12, that might have been there as well. All right, to write a recursive formula, on our sheet they tell us a sub n is a sub n minus 1 plus d. Now we remember when we write a recursive formula, we always have to start out and tell the first term. The first term was 7. I can tell that from my pattern. Then I'm plugging in and I'm writing to get the nth term. I'm going to take a sub n minus 1, which is the term before that, and what am I going to do? I'm going to subtract 5 from it. Now, if this were on an SOL type of question, they would throw on this n is greater than or equal to 2. It doesn't matter to me if you put that there or not, but don't get confused if you see it on a multiple choice. All right, number 8 says find the sum of the following series. So I look at this and have to figure out, are we arithmetic or are we geometric? Every time what I'm doing is I'm multiplying by the same number, and the number I'm multiplying by is 1/3. So when I go to use my sum formula, my sum for a geometric is s sub n is a sub 1 times 1 minus r to the n all over 1 minus r. So I need to know s sub what? What number is going down there? How many terms do I have? Well, in order to figure out how many terms do I have, I need to figure out this last term. What was that? It might help me to write the formula for the terms of the sequence. For a geometric sequence, we have a sub n is a sub 1 times r to the n minus 1. So if I'm trying to figure out what n is, my nth term is 1 over 2,187. My first term was 1, and then I multiplied by 1/3 how many times? Well, probably the easiest way for me to solve this is to just do a little guessing and checking on my calculator. If I have 1/3 and I raise it to the 3rd power, that's 1/27th. That would be the next item in our series. How about if I do 1/3 to the 4th power? I should realize that's going to give me 1 over 81, so that's not going to be big enough. Let me try a bigger one. Maybe I'll try 6. I'll jump up ahead. Okay, 6 isn't big enough. Let's try maybe to change that to a 7. And I'm just sort of doing guessing and checking right here, and I can see, oh, n equals 7 in this. So I need 7 terms. But wait a minute, is that really 7 terms? Because this is 1/3 to the 7th power, but this was 1/3 to the 1st power, 1/3 to the 2nd power was the 1/9. So this is really n minus 1 was equal to 7. So there's really 8 terms. And I could see that if I listed them out. 1 plus a 3rd plus a 9th plus a 27th plus 1 over 81 plus 1 over 243 plus, oops, hold on. Okay, that was 1 over 729 and then 1 over 2,187. So if I counted up these terms, I have a total of 8 of them. So what I'm really looking for here is the sum of the first 8 terms. So I'm going to plug into my formula. The first thing I needed in my formula was the first term. My first term in my pattern was just a 1. And then I had 1 minus my common ratio. My common ratio is a 1/3. I'm writing it in parentheses because it's a fraction. And that was to the nth power in my formula, so I need an 8 up there in the exponent. And all of this was over 1 minus my common ratio, which was again 1/3. Now I need to type this into my calculator. So when I type that, I make sure to put my fractions in parentheses. And I have 1.4997. I'm just going to chop it off or truncate it to 4 places after the decimal. All right, number 9, find the sum of the infinite geometric series. That infinite means this keeps going forever. So my formula for my formula sheet is the infinite sum is a sub 1 over 1 minus r, and this only works when our common ratio, whoops, is less than 1 in its absolute value. So that means our common ratio has to be a little number between -1 and +1. So if I'm looking at this, what am I doing each time? Well, I'm multiplying by -1/3, so that's my common ratio. That tells me that this is going to work because my common ratio is a little number. So I plug into my formula. My first term I needed for the top of the formula was -54. Then on the bottom of the formula, I have 1 minus the common ratio. Be careful because I'm subtracting a negative number here. The other thing I want to be careful of when I go to put this thing in my calculator is that I probably need to double parenthesis the bottom. So I type that in my calculator and it gives me -81/2, or I could turn that into a decimal as -40.5. Doesn't matter to me which way you write it. But again, if it is a multiple choice, you should be able to choose either one. So let's scroll down here to some later questions. Number 10 says write the explicit formula and the recursive formula for the nth term of the following sequence. And I'm starting out with 5 and then -15 and 45 and -135. So I need to find my pattern. What's my pattern? I'm multiplying by a -3 each time. So that means that this is geometric with a common ratio of -3. If I'm going to do an explicit formula, I have a sub n is a sub 1 times r to the n minus 1. So for me, my first term was 5. My common ratio is -3, and I have to leave that n minus 1 in there. I cannot simplify this by multiplying the 5 and the -3 because that order of operations says I'd have to do the exponents first. So I'm just going to leave it like that. For my recursive, I know with recursive, I always start out and I have to give the first term. The first term is 5, and my formula says a sub n is a sub n minus 1 times the common ratio. So I'm just going to plug in a -3 for that common ratio. Again, on an SOL, they'd say n is greater than or equal to 2. You don't have to write that, but if it's a multiple choice, it'll be there. All right, number 11, the fourth term of an arithmetic sequence is 26. So on this one, I've got the fourth term. It helps me to lay them out. Here's my fourth term is 26. Okay, then I have the ninth term is 56. So that's 5, 6, 7, 8. Here's my ninth term is 56. I'm supposed to find the first term, so that's this one, a sub 1, and I'm supposed to find the common difference. So I'm trying to figure out what do I add each time. So let's see, what do I know? I know that I start with 26 right here, and I could add a series of differences. I'd add 1 there, 2, 3, 4, 5 differences. And when I start with 26 and add 5 differences, I need to equal up to 56. So I could solve this equation by subtracting 26 from both sides and then dividing by 5 to get a common difference of 6. That's one of the informations they wanted to know, the common difference. And then I would just work backwards and say, well, normally I'd add 6, so if I'm going this way, I'm going to subtract 6. So 26 minus 6 is 20, minus another 6 gets me to 14, minus another 6 gets me to 8, and there's my first term is 8. I'm going to stop this video now so it doesn't get too long, and then we'll do the second 2 pages of the sample test in the next part of the video.